Therefore, we have this simplified to be minus times of 2 theta plus sine 2 theta by 4 plus c, which is obtained by taking the LCM of these two terms. And hence, the minus of theta, which needs to be replaced with x, because the question is given in terms of x, we need to just convert this into x as required. Therefore, I utilize the constant x equal to cos theta, implies my theta is cos inverse x, is what I get in terms of theta. And finally, sine 2 theta also needs to be converted into x. Therefore, I use sine 2 theta as 2 sine theta cos theta, where my cos theta is x and sine theta is root of 1 minus cos square, that is root of 1 minus x square times this. Therefore, sine 2 theta is 2x times root 1 minus x square. And therefore, I get this to be replaced with this, and which on further simplification by taking 2 common and cancelling, I get minus times of cos inverse x plus x root 1 minus x square by 2 plus c. Therefore, integral of x square by root 1 minus x square is this, using the substitution through trigonometric angle. Now let's find integrals of some special algebraic functions. That is, if I have integral of 1 by x square plus a square dx, then let's see how we can evaluate this integral, because this helps us as a formula in solving many of the problems of this type. So to derive this, I take this in the form. So I have this reduced by taking a square common, and I get 1 plus x square by a square of dx. And then a square being a constant is taken out, and I get 1 by a square integral 1 by 1 plus x by a whole square dx. Now, as this is in the form integral 1 by 1 plus x square dx, which is tan inverse x plus c, I can reduce this in the form of 1 by a square of tan inverse x by a, that is tan inverse of this, but this is in the form f of ax plus b. Therefore, the coefficient of x, which is 1 by a, comes in the denominator, and which we have taken as the rule in the previous case, plus c, and one of the a gets cancelled, and I get this to be 1 by a tan inverse x by a plus c. Therefore, integral of 1 by x square plus a square dx is derived to be 1 by a tan inverse of x by a plus c. Integration of special algebraic functions. Next is integral of 1 by x square minus a square dx, which I need to integrate using the formulae. So as I see this, I clearly understand that x square minus a square can be written as x plus a times x minus a, which on further simplification gives us of dx, because by using the partial fractions, I can split this as 1 by 2a times 1 by x minus a minus 1 by x plus a, which on simplification gives the term above. Now splitting this, we get this in the form integral of this minus integral of this. Now integral of 1 by x is log mod x, because we have the formula integral 1 by x dx is log mod x plus c. So using this, here I get log mod x plus a plus c. Therefore, integration of this is log mod x minus a minus log mod x plus a plus c. Now, which on further simplification gives us 1 by 2a times log a minus log b is log a by b, that is which we're going to use here. I get this to be log mod x minus a by x plus a plus c. Therefore, integral of 1 by x square minus a square dx is 1 by 2a log mod x minus a by x plus a plus c is how we derive for integration of 1 by x square minus a square as a special case of an algebraic function. Now, next is integration of 1 by root a square plus x square dx, which can be simplified in the similar manner as we have derived for a square minus x square. So, in this case, I have root of a square which is taken out, and then I get 1 plus x by a whole square of dx by taking a square within the root. And root of a square is 1 by a, which comes out, and then I get 1 plus x by a whole square of dx. Now, comparing this with the formula which we have already learned in the standard formula, integral of 1 by root 1 plus x square dx is sine h inverse x plus c. So, using this formula, we get this reduced with 1 by a of sine h inverse of x by a, but because this is in the form of f of ax plus b, I get the coefficient of x, which is 1 by a, and this gets cancelled with to get sine h inverse x by a. Therefore, integral of 1 by root a square plus x square dx is sine h inverse x by a plus c. So, sine h inverse x by a is the answer for an integral of the algebraic function of the type 1 by root a square plus x square dx. Now, let's see the integration of the algebraic function of the type a square minus x square of dx. So, integral of this is identified as half x root a square minus x square plus a square by 2 of sine x inverse by a plus c is how we identify the formula of this using the same method of substitution as done in the previous case. Next, integral of root x square minus a square dx is identified as half x root x square minus a square minus a square by 2 of cos h inverse x by a plus c. And finally, integral of root a square plus x square dx or x square plus a square dx is identified as half x root a square plus x square plus a square by 2 of sine h inverse x by a plus c are the three basic formulae relating to special types of algebraic functions which have the respective formulae. Are the three types of functions with their integrals. Next, let's see some related problems as we have discussed in the session. So, for example, I wanted to find the integral of root 25 plus 16x squared dx. Then in this case, I need to integrate using the formula root a squared plus x squared. But let's try to convert this into the form root of a squared plus x squared. So in order to do that, I don't want the coefficient of x squared to be other than 1. So I take 16 common out here so that I get 25 by 16 plus x squared dx, with 16 taken common out of these two. Then this would be nothing but root 16, which comes out, and root of 25 by 16, which is written as 5 squared by 4 squared, that is 5 by 4 whole squared, plus x squared dx. This, on further simplification, root 16 being 4 times root of 5 by 4 whole squared plus x squared dx. Now this is in the form of root a squared plus x squared, where a is 5 over 4. So using this value of a, which is 5 over 4, I expand using the formula, which expands to 4 times root a squared plus x squared, which is half x root a squared plus x squared plus a squared by 2 sine h inverse x by a is what we get, which on further simplification, with cancelling 2 1s 2 2s, and this when simplified gives us, so we have this 2x root of 25 by 16 plus x squared, and then this becomes 25 by 16 times 2 of sine h inverse 4, which comes to the numerator as 4x by 5 plus c, which can be further simplified as 2x 25 plus 16x squared by root 16, which is 4 in LCM, and this reduces to 25 by 32 sine h inverse 4x by 5 plus c. That is, cancelling this, I get the answer as x by 2 root 25 plus 16x squared plus 25 by 32 sine h inverse 4x by 5 plus c is the answer for integral of root 25 plus 16x squared dx. If I have the question which has quadratic equation or the quadratic function in the denominator, these kind of problems are not direct in substitution through the standard formula which we had taken. So in this case, we use the method of substitution, but before this, I can split this as 4x squared written as 2x whole square, and 12x can be written as 2 times 2x times 3. Now this is in the form a squared plus 2ab, where my b squared term is adding and subtracting b squared plus 13 dx. In order to make this a perfect square, I add b squared and minus b squared. Then this would be a plus b whole square, that is a plus b whole square minus 9 plus 13, which on further simplification gives 2x plus 3 whole square plus 13 minus 9, which is 4. This on further simplification gives integral 1 by 2x plus 3 whole square plus 2 square dx. Now this is clearly in the form integral 1 by x squared plus a squared, which on using the formula is 1 by a tan inverse x by a x by a plus c. Therefore, using that formula out there, I get this as tan inverse 1 by a tan inverse x by a whole by coefficient of x plus c is what we get using the function in the form ax plus b. Therefore, this gets cancelled with this, and therefore the answer is tan inverse 2x plus 3 by 2 plus c is what we get for integral of 1 by 4x squared plus 12x plus 13 is tan inverse 2x plus 3 by 2 plus c using the method of substitution. Now next is integration by parts. So how do we integrate by parts? That is, if I have product of two functions, then how do we integrate the product? As in sum and difference, we can split the integral directly without any rule. Multiplication has certain limitations, and therefore the concept of integration by parts. Now here, if I have two functions u of x and v of x, then for these two functions, if I wanted to find integral of ux times v of x dx, then this is possible by using the formula minus integral derivative of first second of dx is how we identify the formula for integration by parts. Integral uv is u integral v minus integral u dash integral v dx, which becomes more easy to follow if I take in the form integral of first function into integral of second function is given as first integral second minus integral derivative of first into integral of second whole of dx. So the memorizing of this concept would be easy in solving the problems related to integration by parts. Integral of first into second function is first integral of second minus integral derivative of first into integral of second of dx is how we memorize this for the actual formula, which is like this. Integration by parts for the functions which are in product form. Now that we have discussed about integration by parts comes the Eilert rule, which is very essential because we have taken the integration by parts as integral of first into second is given by first integral of second minus integral derivative of first into integral of second whole dx is how we have taken for the first and the second function. So using this formula, the biggest question which comes out here is which function will you choose as the first function and which function is chosen as the second function, or is there any rule, or we can choose any one out of our choice. Now in case of this limitations, the Eilert rule is very much applied because you cannot take any function to be the first and second. It's a rule, and which rule says the Eilert rule. So let's follow the Eilert rule in identifying the first function and the second function in order. So the Eilert rule says that I have I, L, A, T, E. That is, there are totally 5 alphabets. Each alphabet represents inverse trigonometric functions, like if suppose I have the functions like sine inverse, cos inverse, tan inverse, etc., then this comes first. Then the second type of function is the logarithmic function starting with L. So the logarithmic function states that the functions of the type log x or log x to base e, etc., are all the logarithmic functions considered. The next is algebraic function of the type x square, x cubed plus 3x, and all types of functions of this type under root are called algebraic functions, which come third in place. Then the fourth type of functions are trigonometric functions like sin x, cos x, tan x, etc., which are the trigonometric functions of the type. Then the next is exponential functions like e power x, a power x, 7 power 2x plus 3, and so on and so forth, which give us the exponential functions. So there are totally 5 types of functions which we have, which are taken in order. That is, if I have the combination of inverse trigonometry and trigonometry, then this comes first and this comes next. If I have the combination of logarithmic and exponential, then logarithmic comes first and exponential comes next. And if I have the combination of algebraic and trigonometric, then algebraic comes first and trigonometric comes next. Therefore, I have e power x times sin x. Then let's decide on which function comes first in case of the product of integration. Then in this case, I clearly see that this is an exponential function and this is a trigonometric function. So t comes first and e comes next. So this is expanded along integral sin x e power x dx, with this being the first function and this being the second function, is how we define the first and the second function dx. So integration by parts is with the rule isolate inverse trigonometry, logarithmic, algebraic, trigonometric, and exponential in order for the first and the second function. Let's see some example problems using integration by parts. Say for example, I would like to integrate x e power x dx using integration by parts. Then clearly I see that this integration includes the algebraic function and the exponential function, and hence using the process of isolate, my algebraic comes first and exponential comes next, and hence I take in the order x e power x dx. Now I have the formula which says integral of first into second is first into integral of second minus integral derivative of first into integral of second of dx. So using this formula, I get this to be the first function and this to be the second function. Therefore, I get first integral of second minus integral derivative of first into integral of second of dx, is how we get this using integration by parts. Now we know that integral e power x dx is e power x, therefore I get x times e power x minus integral derivative of x is 1, because d by dx of x, which is derivative of x, is clearly 1, and hence I get this to be 1, and integral e power x is e power x of dx. Therefore, this reduces to x times e power x minus 1 times of this dx, which on further simplification gives x times e power x minus integral e power x is e power x plus c. And therefore, integral of this is obtained as e power x taken common of x minus 1 plus c. So integral of x e power x dx is e power x times x minus 1 plus c, using integration by parts and the Eilert process.